Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. I am Puan Nufazila binti Umar Yusof, and today we will learn the Einstein's photoelectric theory in quantum physics. There are three learning standards in this lesson. Number 1, state minimum work function needed by a metal to emit an electron using Einstein's equation. Number 2, explain the threshold frequency F0 and work function W. Number 3, determine work function of a metal. Before we jump to our learning objectives, we need to go through to the historical processes which takes us to the theory. In 1905, Albert Einstein extended the idea of energy quantization by Max Planck in Planck's quantum hypothesis to explain about the photoelectric theory. In order to learn the Einstein's photoelectric theory, we need to recall Planck's quantum theory. Thanks to Max Planck, who discovered the energy quanta, and he is the father of quantum theory. First, energy is not emitted or absorbed continuously. It is emitted in the form of wave packets or quanta. In case of light energy, it is known as photon. Photon was introduced by Einstein. Next, Planck quantum theory explains that amount of energy associated with quantum of radiation is directly proportional to the frequency of the radiation, E equal to hf, where h is Planck's constant. Albert Einstein extended Planck's quantum hypothesis and used it to explain the photoelectric theory. Einstein's photoelectric equation explains that when a photon of energy falls on a metal surface, the energy of the photon is absorbed by the electron and used in two ways. A part of energy is used to overcome the surface barrier and come out of the metal surface. This part of energy is called work function W equal to hf naught. Remaining part of the energy is used in giving a velocity to the emitted photoelectron. This is equal to the maximum kinetic energy of the photoelectron, half mv maximum square, where m is mass of the photoelectron. Einstein's photoelectric equation applied the principle of conservation of energy, where E, which is photon energy, equal to W, which is minimum energy required to release a photoelectron, or known as work function, plus K maximum, which is maximum kinetic energy of the photon. The photon energy E equal to hf is from the Planck's theory, and hf equal to W plus half mv maximum square. When we rearrange the equation, it becomes half mv maximum square equal to hf minus W, which is work function. Threshold frequency F0 is defined as minimum frequency of radiation required to eject an electron from the surface of the metal. And also, at the threshold frequency F0, photoelectrons are emitted without any kinetic energy, half mv maximum square equal to 0. At threshold frequency F0, hf equal to W plus half mv maximum square, and when we rearrange the equation, it will become half mv maximum square equal to h f minus f0. Now, I wonder how to determine the work function of a metal. So I have a few types of light-sensitive metals here, and we need to determine its work function. So what is work function? Work function is the minimum energy required to emit or to eject or to expel electron from the metal's surface. So work function is part of the Einstein's equation in Einstein's photoelectric theory. So this equation apply the principle of conservation of energy where E equal to work function plus kinetic energy. So E, energy here is from the Planck's equation, E equal to HF. So E or HF equal to work function plus kinetic energy. If kinetic energy maximum equal to 0, so F frequency equal to threshold frequency. So W minus H F naught equal to 0 and then W equal to H F naught. So let's try for tantalum and we find the work function in joule. The F naught is 1.03, so the threshold frequency equal to 1.03 times 10 power of 14 Hertz. So we change the unit to per second and then we will get the answer as 6.8289 times 10 power of negative 20 joule. Alright, now how about work function of the metal in electrovolts? Okay, so 1 electrovolts equal to 1.602 times 10 power of negative 19 joule. So what we need to do here is, so we need to change the joule to electrovolt. Alright, we can cancel off the unit and then we will get the answer in electrovolt, which is 0.4268.
Thank you, teacher. Now, I can state the minimum work function needed by a metal to emit an electron using Einstein equation. I am also able to explain threshold frequency, F naught, and work function W. I also can determine the work function of metal using the equation W equals to H F naught.